First thing first, we need to know all the information and use the first percentage, which is 6% for the first 2 years. P is 7,500 ringgit, I is 0.06 over 6, N is 6 times 2 equals 12, T is 16 April 2016 to 16 April 2018 is equal to 2 years. The formula that we're going to use is S equals P 1 plus I power N. Now, we substitute the value to the formula. 7,500, 1 plus 0.06 over 6 power 6 times 2. Do the equation, you will get 7,500, 1.01 power 12. And the answer for the 2 years is 8,451 ringgit 90 cent. We will use the 8% percentage. Answer from the 2 years, which is 8,451 ringgit and 90 cents, will be the P. I is 0.08 over 4, and we can make the number smaller, 0.02. N is 4 times 1.5 years equals to 6. The T is 16 April 2018 to 16 October 2019 is 1.5 years. Write the formula, which is S equals P 1 plus I power N. And then we substitute the value to the formula. 8,451 ringgit 90 cents, 1 plus 0.08 over 4 power 4 times 1.5. Do the equation, you will get 8,451 ringgit and 90 cents, 1 plus 0.02 power 6. And then we settle in the bracket first. And you will get 8,451 ringgit and 90 cents, 1.02 power 6. And the final answer is RM 9,570 and 41 cents.
First, I calculate the future value for Alpha Bank. Alpha Bank offers 4.35 interest compounded every 4 months. The formula used S equal P 1 plus I and P equal RM 48,000, I 0.0435, M equal 3 times per year because every 4 months. N equal 3 multiply 3 equal 9 compounding periods. After substitute all the values, the future value becomes RM 6023.18. Next, for Omega Bank, the annual interest rate slightly higher at 4.15% and it is compounded monthly. P equal RM 48,000, I equal 0.045, M equal 12, N equal 12 multiply 3 equal 36 periods. After calculate the value using the same formula, the future amount becomes RM 366.37. Conclusion: Mr. Daniel should choose Omega Bank because it generates a higher profit compared to Alpha Bank.
Okay, let's break down what's happening here. Mr. Daniel initially deposited 58,000 into a bank account. The bank pays interest at 4.5% per year, compounded monthly. We want to know how much money he will have after 6 years, but with one important twist. At the end of 4 years, he withdraw 50,000. So we must calculate first how much the money grows in the first 4 years, 2 subtract 50,000 and 3, then grow the remaining balance for another 2 years. Step 1, we have to grow it for the first 4 years. We start with the compound interest formula, S equal P1 plus IN, where P is 58,000, I is 0.054 over 12 monthly interest rate, and N equal 12 multiplied 4, 48 months. So after substitute, we have S equal 58,000 P1 plus 0.00375 I and 48. And if we calculate this, we will get S equal RM 69,415 and 23 cents. This means after 4 years before withdrawal, the account has 69,515.23 cents. Mr. Daniel now withdraw 50,000, so we have to minus it with the amount in the account. So 69,450.23 cents minus 50,000, and we will get 54,450.23 cents. New amount becomes the new principal for the next 2 years. Now we have to compound again for the remaining 2 years. P is 54,415 and 23 cents. I is 0.045 over 12 and N is 12 multiplied 2 years 24. So we got S equal 54,450.23 cents. 1 plus 0.045 over 12 power 12 multiplied 2. This gives S equal 59,529 and 72 cents. This is the final amount left in the account after 6 years.
So now I will explain part B question 1. This question is about an investment fund that will provide scholarship payments for 10 years. First, we need to understand the problem. Based on the question, it says a local university wants to give scholarships for the next 10 years. They need to pay 5,500 ringgit every 6 months. To make this sustainable, the university wants to deposit a lump sum now into an investment account that earns 3.8% interest per year, compounded half yearly. Because the interest is compounded half yearly, so the M should be 2. And the K should be 3.8% per year. So the interest per period is 1 equal K over M equals 0.038 over 2. So now I equal 0.019. Then the payments happen every 6 months for 10 years. So N equal M multiply T equal 2 multiply 10. So now N equal 20 periods. Then we use the ordinary annuity formula. This is an annuity question because the university needs to withdraw a fixed amount every period. We use the formula S equal R multiply open bracket 1 plus I close bracket power N minus 1 over I and close the bracket. So now we substitute the values. S equal 5,500 multiply in bracket 1 plus 0.019 close bracket power 20 minus 1 over 0.019 and close the bracket. Then calculate 1.019 power 20. Now it's 1.45708,095. So now S equal 5,500 multiplied in bracket 1.45708,095 minus 1 over 0.019. Now S equal 5,500 multiply 24.05689211. So the final answer is RM 132,312 ringgit 91 cents.
First, I will list all information from the question. S equals to RM 132,312.91 cents, which is from the A. T equals 4 years. K is 2.5. We can make the number smaller, 0.025. M equals 12. Next, write the formula. S equal R in bracket 1 plus K over M power M times T minus 1 over K over M. And then we substitute the value to the formula. 132,312.90 cents equals R in bracket 1 plus 0.025 over 12 power 12 times 4 minus 1 over 0.025 over 12. And then we do the equation. 132,312.91 cents equals R in bracket 50.42686,128. And then 132,312.91 cents over 50.42686,128 equals R. The final answer is R equals RM 2,623 ringgit 86 cents.
In this question, you are required to calculate two things. First, the monthly installment R that Mr. Adi needs to pay to fully settle the loan, and second, the total interest he will pay over the entire loan period. You can see in this question, A is 29,550 multiply 70 over 100, so A is 20,685, K is 6.7%, convert it to decimal is 0.067, M is 12 and T is 5 years. To solve the problem, the formula for the monthly installment of a compound interest loan is used. A equal R 1 minus 1 plus K over M minus MT over K over M. We have to calculate the amount in the bracket first until we get 50.86479,271 and multiply with R until we get 50.86479,271 R and divide the 20,685 with 50.86479,271 until we get the final answer for R is RM 406.67 cents. To complete the question, we have to calculate the interest by using formula R multiply N minus E. And we have to substitute all the information and we get 406.67 as R multiply 60 N and minus 20,685 is A. Calculate the amount in the bracket first until we get 24,420 cents and minus it with 20,685 and we got the answer for the interest is RM 3,750 and 20 cents.
To determine how many months of payment he missed, I use the annuity formula S equal R 1 plus I and minus 1 per I. S equal RM 2894.82, R equal RM 406.67, I equals 0.067 per 12. I substitute all the values and rearrange the formula to solve for N. I use log 1.0397 for 4.29 per log 1.00558 33333 per N. Then the result show that the numbers of missed payment is approximately 7 months. So Mr. Adi has missed around 7 monthly installments.